Up until now, when using trig, we've always been given the degree measure of an angle. But what if we want to work backwards, and instead of being given the degree measure of the angle, we're instead given the trig ratio of the angle? Is there a way that we can work backwards in order to determine angle measure? The answer to that is yes, and we can do this by using something called inverse trig. I like to think about inverse trig as just working backwards, whereas now we're being given the ratio and asked to instead find the degree measure of the angle. So for instance, if we know that the sine of some angle A is equal to 0.6, can we work backwards and find the degree measure of that angle? The answer is yes, and in order to do that, we're going to use something called inverse trig. So inverse trig on your paper is going to look like this. Inverse sine, we want to use inverse sine to work backwards from the sine function. And if I take the inverse sine on the left side of my equation, I also want to take the inverse sine on the right side of my equation. So sine and inverse sine undo each other. They cancel each other out. So I'm left with, on the left-hand side of my equation, the measure of angle A, and on the right-hand side, I've got inverse sine of 0.6. And I'm going to find the value of inverse sine of 0.6 using my calculator. Now, just like before, I always need to check my document settings and make sure that my document settings are set to float 12. And to degrees. I'm going to go ahead and make that the default. And now I can go ahead and open up a new document. And I'm going to find inverse sine in the same spot I find all of my trig functions on my calculator, right there under that trig button. But now I'm going to use this little inverse sine, which is right underneath the sine function that we've been using. And I'm just going to punch this in. And what this will tell me is the degree measure of the angle whose sine value is equal to 0.6. Now, it doesn't tell me exactly what number to round to. So instead of saying the measure of angle A is equal to, I'm going to say the measure of angle A is approximately equal to, and I'm going to round to the nearest degree, about 37 degrees. And then I can do this for all of these. If I'm told that some angle has a cosine value of 3/4, to undo taking the cosine of an angle, I'm going to use inverse cosine. And again, cosine and inverse cosine undo each other. So on the left side of my equation, I'm left with a measure of angle theta. On the right side of my equation, I need to now go figure out what the inverse cosine of 3/4 is equal to. So about 41 degrees. And again, I want to change this and make this an approximately. And then to undo taking the tangent of an angle, I'm going to take the inverse tangent. So inverse tangent on the left. I want to do an inverse tangent on the right. And again, the tangent and the inverse tangent cancel, and I'm left with the measure of angle x. And to find that value, I'm again going to punch into my calculator. So about 21 degrees. All right, I'm going to ask you to pause the video at this point and go ahead and use your calculator in order to determine the measure of angle A. And this time they're telling us again to round each angle to the nearest degree. Okay, so the first one I had that the measure of angle A was approximately 77 degrees. For the second one, angle A measured approximately 7 degrees. For the third one, the measure of angle A was exactly 60 degrees. And then lastly, for the fourth one, the measure of angle A was approximately 63 degrees. All right, so now that we know how to use inverse trig, we can use it to solve some questions involving some triangles, and that's what we're going to do in the problems at the bottom of the page. Just like when we used trig before, we're always going to start by labeling the hypotenuse, the side opposite the given angle, and the side adjacent to the given angle. So in this particular problem, I'm going to label the hypotenuse 32, the adjacent side is 14, the opposite side has no value given to us. So I can tell by looking at this question that we want to use the trig function that deals with the adjacent side and the hypotenuse. And just a quick reminder that the sine value is the ratio between the opposite and the hypotenuse. Cosine value is the ratio between the adjacent leg and the hypotenuse. And the tangent value is the ratio between the opposite leg and the adjacent leg. Since we want to use the trig value that deals with adjacent and hypotenuse, the one that we want to use for this particular problem is the cosine ratio. So I know that the cosine of my angle theta is equal to the adjacent side, which measures 14, over the hypotenuse, whose measure is 32. To undo taking the cosine of an angle, I'm going to use the inverse cosine feature. And if I do that on the left side of my equation, I also need to do that on the right side of my equation. So a cosine and an inverse cosine cancel each other out, and I'm left with a measure of angle theta. On the right side, I can now use my calculator to evaluate the value of cosine inverse of 14 over 32. So I'm going to use inverse cosine of the ratio 14 over 32. And since they're asking us to round that to the nearest degree, I'm going to say that the measure of that angle theta is approximately 64 degrees. So I'm going to go back and change the equal sign and make it an approximately 64 degrees. All right. The next problem I'm going to approach in a very similar fashion. I'm going to go ahead and start by labeling the hypotenuse, the angle opposite theta, and the leg opposite theta, and the leg adjacent to theta. This question now deals with the opposite and the adjacent. So I want to use the trig function that deals with opposite and adjacent, and that's the tangent function. So I know the tangent value of my angle, which is theta, is equal to the leg opposite, 26, over the leg adjacent, 18. To undo taking the tangent of an angle, I'm going to use inverse tangent. And if I take the inverse tangent on the left side of my equation, I also need to take the inverse tangent on the right side. So tangent and inverse tangent undo each other. I'm left with the measure of angle theta. And now I'm going to get my calculator out to evaluate inverse tangent of 26 over 18. So when I go ahead and do as specified in the directions and round to the nearest degree, I find that the measure of that angle theta is approximately 55 degrees. Okay, As always, I'm going to ask you to summarize the key takeaways up at the top of the next page, and then see if you can apply the knowledge that you've gained in this video in order to solve the problems on page 7.